everyone. Today we are going to learn how to solve triangles using the law of sines. So in the last lesson we learned how to solve triangles using SOHCAHTOA, and those triangles had to be right triangles. This time around we can solve any triangle by using the law of sines. Before we get started, I would like you to please go ahead and factor the following three expressions. The first expression is 2x cubed minus 3x squared minus 9x. The second expression is 4x squared minus 48x plus 144. And the third expression is 100x squared minus 25. Please keep your eyes peeled for an opportunity to factor out a greatest common factor in order to factor each expression completely. Please pause the video when you factor, and then when you have an answer, please restart the video and we'll see how well you did. All right, let's look at the first example, the first problem. We have 2x cubed minus 3x squared minus 9x. And all of these terms have in common an x. So I'm going to factor out an x, and my leftovers is a 2x squared minus 3x minus 9. I'm going to try to factor this expression into two parentheses by splitting apart the 2x squared into a 2x and an x. And I'm going to work with the factors of 9, and somehow I have to work with the factors of 2 and 9 and come up with a negative 3 in the middle. Now, whenever I think of 9, I always think of 3 and 3, and then I think of 1 and 9. So I'm going to try 3 and 3 first. My goal is to get a negative 3. So I'm going to multiply 2 times 3, which is 6, and then 1, there's an invisible 1 right here, times 3 is 3. And 6 and 3, can I get a negative 3? The answer is yes. If I were to subtract a negative 6 and add it to a negative 3, negative 6 plus 3, my answer would be negative 3. So I need a negative 6, which means that I'm going to be multiplying 2 times a negative 3, and I'll be multiplying a positive 1 times a positive 3. And I can check. 2 times negative 3, that's negative 6x. And 3 times x, that's a positive 3x. And negative 6 plus 3 is negative 3. Awesome. So there's my first factorization. The next one, we have 4x squared minus 48x plus 144. And all three of these terms have in common a 4. So I'm going to factor out a 4, and my leftovers is x squared minus 12x. And then 144 divided by 4, that is equal to 36. So I'm going to write plus 36. Now, x squared minus 12x plus 36, this is called a perfect square trinomial. So you're more than welcome to break it down into two parentheses if that's what you need, but you really don't have to because this is a perfect square trinomial, which means it'll factor down into a parenthesis squared. So the way you come up with your answer is this. X squared, you take the square root of it. That's an x. The sign of b is a minus, so we'll have a minus, and the square root of 36 is 6. So our answer is 4 times x minus 6 squared. And finally, 100x squared minus 25, both of these terms have in common a 25. So when I factor out a 25, I am left with 4x squared minus 1. Now 4x squared minus 1, that's a dots. A difference of 2 squares. Now, if you notice from the beginning that you had a difference of 2 squares and you broke it up into 10x plus 5, 10x minus 5, that's not incorrect. That is correct, but you still need to factor out a GCF, so I'll show that in just a second. So we have 25 times 2x plus 1 times 2x minus 1. So let's say that you didn't see this. This is our correct answer. But let's say that you factored it into a 10x plus 5 times a 10x minus 5. This would be not correct because you didn't factor it completely. There still exists a perfect square factor in each parentheses. 10 and 5 both have in common a 5. So I'd factor out a 5 and I would be left with 2x plus 1. And then 10 and 5 once again both have in common a 5. And then we would end up with 2x minus 1. Now the 5's on the outside can be multiplied because this is just multiplication and the order in which you multiply does not matter. So if you were to multiply 5 times 5, you would still end up with 25, x plus 1 times x minus 1, and you could still end up with the correct answer. So if you are struggling with factoring, please, please, please make sure that you come and see me so that we can have a conversation about factoring because it is not going away, and like I said before, and like I've said always, it's on every single test throughout the rest of the semester. So our learning targets for today is for you to be able to say, I can use the law of sines to solve any triangle. So it does not have to be a right triangle. It can be any triangle given angle, angle, side, and angle, side, angle. Then the next part is I can find the area of any triangle if I am given side, angle, side. So you'll need to remember what angle, angle, side, and angle, side, angle looks like. So just as a reminder, if you know an angle, and you know an information about another angle, and then you know something about a side, this is called angle, angle, side. So you know two angles and then a side, and the side is not in between the two angles. Angle, side, angle, this is called angle, angle, side. Angle, side, angle is where you know an angle, we'll call it angle A, and you know a side, we'll call it little c, and you know angle B. So that's what you know and what you start off knowing, and this is called angle, side, angle. And what makes it angle, side, angle is the fact that the side that you know is in between. And then finally we have side, angle, side. So side, angle, side, that looks like where you know a side, we'll call this A, here's B, and here's C, and we know a side, we'll call it little c. We know an angle, we'll say that we know angle A, and then we know another side, which is B. So that's called side, angle, side. And so those are the different forms that we are going to be working with in this lesson. So far, like I said, we've solved right triangles. But what can we do when the triangle does not have a right angle? Well, we know two angles. When we know two angles and a side, or two angles and a side opposite of one of those sides, we can use what we call the law of sines. And the law of sines is a proportion where it's little a divided by the sine of angle A, little b divided by the sine of angle B, and little c divided by the sine of angle C. So notice our picture. We have little a, which is across from angle A, and little b, which is across from angle B, and little c, which is across from angle C. This is how you should label every single picture. So label each triangle just like this. You need to have angle A and side A being across from one another. So how do you know when to use the law of sines? Well, I call the law of sines the two of a kind. The two of a kind rule. So what that means is that you'll know two of a kind for one variable. What I mean by that is we will know angle A and side A. If you know two A's, you can use the law of sines. Likewise, if you know two B's, angle B and side B, you can use the law of sines. And if you know side C and angle C, then you can use the law of sines. So if you know to start the problem, two of a kind, we use the law of sines, and we would set up a proportion in which we would match two of these fractions together. You can match A over the sine of A with C over the sine of C. You would match B over the sine of B with C over the sine of C. You just match two fractions together and then set up a proportion to solve the triangle. Now remember that the language to solve a triangle means that you need to find all angles and all sides. So we even list given information whenever we are trying to find things that are missing. So we want to find all angles and all sides. So the first thing I'm going to do is I'm going to draw a picture representing each of my situations, making sure that when I do find my angles are rounded to the nearest whole degree and that my sides are rounded to the nearest hundredth. Okay, so the first thing that we have is we want to solve triangle A, or triangle ABC, given that angle A is 28 degrees, angle B is 102 degrees, and little a is equal to 8. Now 102 degrees indicates that this is an obtuse triangle. So what I would recommend that you do is you draw an obtuse triangle to the best of your ability. My obtuse angle is angle B, and I'm going to make that 102 degrees. Here is A and here is C. Little a is going to be across from angle A. Angle A is 28 degrees. and little a is equal to 8. And I'm going to label across from angle B, little b, and across from angle C, little c. So I want to identify what the measure of angle A is, which is 28 degrees, the measure of angle B, which is 102 degrees, and the measure of angle C, which I can use my 180-degree rule to find out what angle C is, because all angles of a triangle add up to 180. So I'm going to go 180 minus 102 minus 28. And 180 minus 102 minus 28, that's going to equal 50 degrees. So that is what the measure of angle C is, 50 degrees. Cool, I now need to identify what little a is, which I know is 8, little b, and little c. And this is where we get to use the law of sines. So I know 2 of a kind, so I'm certainly going to be working with little a divided by the sine of angle A, and I'm going to set it equal to little b divided by the sine of angle B. So I can find little b using my b information, and I'm even going to put in this 50 degrees right here, because that's going to be coming into play a little bit later. So I know that little a is equal to 8, and I'm going to divide it by the sine of angle A, which is the sine of 28 degrees. Now, because this is degrees, you want to make sure that your calculator is in degree mode before you do anything. And once again, in order to change your calculator into degree mode, you have to press mode, which is located next to second, and you need to make sure that the degree symbol is highlighted. If it is not, then you might have to use your down arrows and your right arrows in order to highlight the degree word, and then press enter so it's in degree mode. This is equal to b divided by the sine of angle B, which is 102. And now this is a proportion where I can just use cross product. So I'm going to write 8 times the sine of 102. That is equal to b times the sine of 28 degrees. In order for me to get b alone, I'm going to divide both sides by the sine of 28. And now I can put this entire thing into my calculator exactly as I see it. I would strongly recommend that you use parentheses, so I'm going to show you how to do that really quick. 8 times the sine of 102, and I'm going to close my parentheses because I'm just taking the sine of 102, and I'm going to divide it by the sine of 28. Closing the parentheses, I end up with 16.67. So I'm going to say 16.67 units is equal to b. So I'm going to write 16.67 units, and I'm going to put units up here next to 8. And now I need to find what little c is. Now, unfortunately, you cannot use the Pythagorean theorem because this is not a right triangle. So once again, we're going to be working with the law of sines. So this is where you're going to be working with that 50 degrees, because I'm going to identify what little c is by using the formula a divided by the sine of angle A, because that's my given information, divided by, or is equal to c divided by the sine of angle C. So I have 8 divided by the sine of 28. That's going to be equal to little c divided by the sine of angle C. So that's the sine of 50 degrees. And once again, I'm going to use cross product so that I end up with 8 times the sine of 50 is equal to c times the sine of 28. I'm going to divide both sides by the sine of 28 so that I can get c alone since I'm multiplying. Sines of 28 will cancel out, leaving me with c is equal to 13.05 units. And you are done. Let's go ahead and look at letter B. Letter B, I am told that triangle ABC, in triangle ABC, angle A is 51, angle B is 44 degrees, and I'm given what little c is. So in this problem, I don't know what type of triangle I have, so I'm just going to write that this is angle A, here's angle B, and I'm going to call this angle C. And little a is across from angle A, little b is across from angle B, and little c is across from angle C. So I know that angle A is 51 degrees, angle B is 44 degrees, and little c is equal to 11. So I'm going to write the information that I do know. Measure of angle A is equal to 51 degrees. The measure of angle B is equal to 44 degrees. And I do not know what the measure of angle C is, but I can find it right away by using my 180-degree rule. So this is a problem where we don't have 2 of a kind, but we can find 2 of a kind very easily. This is the time when you'll have angle, side, angle. In the last example, this was angle side that was given to us because we were given an angle, and a side. So this is called angle side. That's what was given to us in our first example. But we can easily identify what angle C is, like I said, by using our 180-degree rule. So I can write 180 minus 51 minus 44. And when I put that into my calculator, I end up with a measure of angle C is equal to 85 degrees. So now that I know that the measure of angle C is equal to 85 degrees, I now have two of a kind. And I can find what little a is, and I can now find what little b is. Now when it comes to what I did in the beginning where I set up a proportion using the variables, you do not need to write that every single time, and I am not going to do that in letter B. I'm just going to hop right into my problem. I know my two of a kind are C's, so I'm going to start with what I know. 11 divided by the sine of 85 is equal to little a divided by the sine of angle A, which is 51. So now I'm going to use cross product, and I have 11 times the sine of 51 is equal to a times the sine of 85. I'm going to divide both sides by the sine of 85 in order for me to get a alone, and I end up with a is equal to 8.58 units. So little a is equal to 8.58 units. Little b, I don't know what that is, but I do know that little c is equal to 11. So I have to find what little b is. So I'm going to work with my given information again. So I have 11 divided by the sine of 85, and now I want to find what b is. So b is going to be divided by the sine of angle b, and the sine of angle b is 44. So this is the sine of 44 degrees. And once again, I'm going to use cross product. So I have 11 times the sine of 44. And that's going to be equal to b times the sine of 85. I'm going to divide both sides by the sine of 85, and I'm going to put that whole thing into my calculator. And when I do that, I end up with b is equal to 7.67 units. And down here we have 11 units, and that is the end. We've just solved our triangle. So now I'm going to go ahead and move on to identifying the area. So this time around, I'm going to identify the area of a triangle where I am given side, angle, side. So this is, we already know that in order to identify the area of a triangle, it's 1/2 base times height. But what happens when you do not know your height? Well, some mathematicians came up with a way to work with sine as well as cosine, which is something we're going to learn about later on, to find our area. So the area of any triangle is given by 1/2 the product of the lengths of two sides times the sine of their included angle. So what needs to happen is you need to know side, angle, side in order to use this formula. So this is a formula that I need you guys to please make sure that you know and study for your test. This is the side, angle, side area formula. And the way that you do it is this. Area is equal to 1/2 b times c times the sine of the included angle, or 1/2 a times c times the sine of its included angle, or 1/2 a times b times the sine of its included angle. So it depends on what's included and what's given to you. So if we were to look at example number 5, it says a piece of land is bordered by 3 roads as shown. Find the area of the land. We are given our side, our angle, and our side. So I'm just going to plug it into my formula. A is equal to, well, let me make sure that I label this correctly. 2.3 is equal to little b. 1.4 is equal to little a, and that's because these sides are across from the respective angles of A and B. And then we know angle C. So I'm going to work with the formula 1/2 A times B times the sine of angle C. So my area is going to be 1/2 A, which is 1.4, times B, which is 2.3, times the sine of angle C, which is 78.1. And all you have to do is put this whole thing into your calculator exactly as you see it. So let me show you what that looks like. I'm literally going to put into my calculator 0.5 times 1.4 times 2.3 times the sine of 78.1. And I'm going to close my parentheses, and I end up with 1.5, let's round to the nearest hundredth, 1.58 miles squared. So this is area. So area, our units are always squared. So this is 1.58 square miles. And that is our answer. That is it. That is all you do. Let's go ahead and look at example number 6. So in example number 6, it says you are setting up a triangular flower garden in your backyard. If you lay off lengths of 15 feet and 11 feet for 2 of your sides of the garden with a 62-degree angle between these 2 sides, what will the area of the garden be? So once again, we have our triangle. We just need to draw a basic triangle. I'll call this A, I'll call this B, I'll call this C. And let's say that angle A is 62 degrees. And we're told that the other side lengths, I'll call this little b is equal to 15 feet, and I'll call little c 11 feet. And 62, like I said, is the angle that's in between these 2 sides. So I'm going to be working with 1/2 little b times little c times the sine of angle A. So the area is going to be equal to 1/2 times b, which is 15, times c, which is 11, times the sine of 62 degrees. And I'm going to put that into my calculator exactly as I see it. You might want to change 1/2 to 0.5 so it's a little bit easier to enter. But in the end, you're going to end up with 72.84 feet squared. And that is your answer. Now, the one thing I need you to know for this video is that notice that I've worked with little letters and capital letters. Please note that the lowercase letters is equal to your sides, and your uppercase letters, that is equal to your angles. So please be careful whenever you're doing your homework that you pay attention to how you label your sides and angles. That is the end of today's lesson. If you have any questions over anything, please feel free to email me or come and see me after class. Otherwise, I hope you have a wonderful day.